Hello and welcome to Sudoku. Here is a Japanese sum Sudoku puzzle that was set by Dutch author Groot Kormelink, and it was published on Logic Masters Deutschland in January of 2021. And at this point, the puzzle has been sold 63 times and has a rating of 98%, which is huge. But that's no surprise, Tom is an excellent author. And the difficulty is rated 3 stars out of 5, which means it should be somewhat challenging, but not impossible. Okay, so the rules are, well, the usual rules of Sudoku. And some cells have to be shaded. And the clues outside the grid indicate the sums of the digits in continuous blocks of white cells. Let's have a look. For example, this 24 could be, let's say, 7, 8, 9. This 7 could be 2 plus 5. And then we could have any other digits with shaded cells. Well, obviously, I won't shade the cells this way because I would have no room left for the digits, but that's the point. So those are shaded cells, those are unshaded cells, and so white cells mean unshaded cells, and that's it. So the contiguous blocks of unshaded cells have those sums, and they must be separated by at least one shaded cells. It could be several of them. And when we have a question mark, then this can be any number between 1 and 45. Okay, let's start. Where should I start? We know that the sum of all digits is 45. That's what Simon Anthony calls a secret. And I share it with you as much as he does. So here we have a total sum of 41, meaning that a total of 4 is shaded, because the remainder must be shaded. And we have 2 gaps, so digits 1 and 3 will be shaded somewhere in this column, and the remaining cells must form those sums. So 10 needs at least 2 cells, 11 needs at least 2 digits, and 20 needs at least 3 digits. So now we know that those won't be shaded. This one will be shaded, and I think I'll mark the shaded cell this way. Those 3 won't be shaded, this one will be shaded, those one won't. And this is a 1-3 pair. Now, how will we achieve those? How will we dispatch the remaining digits to form those sums? Well, 10 can be 4 plus 6, in which case 11 has to be 2 and 9, and 5, 7, 8 remain for the 20 sum. Another option would be to have 2 and 8 for the 10 sum, 5, 6 for 11, and 4, 7, 9 for the 20 sum. And both of those options seem to work. So we have to put on more work. What next? So that's interesting. We have a total of 34. So there are at least one. So 11, we have 11 for outliers, for shaded cells. They add up to 11. There are at least 3 shaded cells. Oh, and there can't be more than 3 shaded cells, because I said that the outliers add up to 11, and there's only one way to have 11 as a sum of 4 different digits, and that is this. And we know, oh no, we know that here 1 or 3 has to be shaded. That's interesting. So 4 shaded cells is a possibility, except that it's not, because of this 3. This 3 has to be either the single digit 3 or 1 and 2. And in both cases, we see that it's not possible that all of those be shaded. So we only have 3 shaded digits to make this 11 shaded sum. And these are 3 separate digits. So this isn't shaded, this isn't shaded, because the 3 shaded cells will separate the blocks. And now this 3 is either 1 cell, but will that work? It could work. Then it would have to be part of this 26. We would have a shaded cell here and a 2, an unshaded 2 here. That looks possible, but this could also be a 2 with a 1 here and a shaded 3 there. Then those would be shaded, this one would be shaded, and 26 will be done here. So no clear disambiguation here. So this could this be a 1? This could be a 1 with a 2 here. 1 would be part of the 26, and there would be a 2 here. So this is 1, 2, or 3, but I don't think I can find more. But I know, oh, I see. I know that all separators are 1 digit only, so those must be real digits. And 14 needs 2 digits in the sum. So that's the 14. And I need a shaded cell here. So this 3 must be done with only 1 cell. And that disambiguates the 1-3 pair. No, sorry, I disambiguated the wrong way, as I usually do in contests. So now 14 is made of 2 digits, and now we get an 8, sorry, one of those must be 1 digit, the other must be 2 digits. And we need 2 cells to add up to 10. I think that it's not possible for 8 to be 2 digits, because they would need to be 2 and 6. The 9 would be here. And 14 couldn't be done, because 14 uses either 6 and 8 or 5 and 9, and that is not an option. So I think this proves that 8 has to be here. We have a shaded cell here and 2 unshaded cells to produce the 9. Now, because of 8, 14 must be 5 plus 9. Now, because of 1, 5, and 3, only 7 remains as an odd digit to produce the 9. So this is a 2-7 pair, and we get 4 and 6. And those 3 digits really add up to 11. Now this 2 has to go in this cell, this is shaded, and we need a sum of 26. We need at least 3 cells, 9, 8, and 6 would work. We could have an additional 1. 6 cells is possible as well, but not 7. 7 cells have a minimum sum of 28, so this cell must be unshaded. Right. What should I consider now? Not easy. Oh, this is part of this 21, so it must contain at least 3 cells. Those aren't shaded. This now is part of either 10 or 12, so it has to contain at least 2 cells. 21 could use 5 cells or 3, not sure about that. Even 6 cells actually. No, not 6 cells, because it would mean that the 6 cells contain the digits from 1 to 6, and there would be no way of producing these 5. So this is either 3 or 5 cells. Do we know more about this? This 2 could still be 9 and 2 with 5 and 9. Here we have a total sum of 36, so the outliers add up to 9. We could have 2 one-cell separators, or 1 and 2, or 2 one-cell separators and 1 shaded cells on the outside. This is intriguing because we know we have at least 3 separators. We could have 2 separators here and 1 there, or 2 here, 1 there, or even 2 separators, 1 there and 1 shaded cell here. That's not easy. That's a sum of 28. So there's 17 outside. 17 could very well be 8 and 9 in those cells. Really not that easy. Now, could all of these 3 cells be shaded? If this were the case, then I would have 10, 12, and 7. No, I need at least 5 cells to produce those sums, plus 2 separators, so they occupy at least 7 cells, so they must use this. And 10 uses 2 cells, so 10 is here. And now I think there can only be 1 separator here, so we need 2 more separators here. So I need a shaded cell here and a shaded cell there, and unshaded cells here. So that's 2 sums. There's 1 sum here, another sum here, but we don't know the totals. But there will be 1 or 2 shaded cells here. Now, can this be unshaded? If this is unshaded, then that's 1 sum, separator, sum, separator, sum, separator. That's a possibility. Still not quite sure what to do with all of this. So now this is a total of 29. 10 could be 1 or 2 or 3, even 3. I could have 1, 2, 3, 4 here, and a 7 there. No, 1, 2, 3, 4 would totally prevent me from having a sum of 10 here. By the way, oh, this 10 can be determined. It doesn't use a 2 or 3, and it can't be 5 plus 6, 4 plus 6, so it has to be 1 and 9. And now I know that this is a 5, this is a 9. And now I know that this 11 can't be 2 plus 9, so this option must be ruled out. This is 5 and 6. 2, 8 at the top, and 4, 7, 9 here. Well, the cells are too small, but I'm keeping this for reference. I can erase that as well. Now, what about this? I still need 3, 4, 2, and 7. This is part of the 17. It can't be part of the 3, obviously. So 17 has to span those 4 cells, and 9 wouldn't work because none of those cells contain a 1, so the minimum would be 9, 5, 4, and 2, and that is much more than 17. So this has to be a 1, and this is a 9. So we need 17. It could be 5 cells. 1, 4, 1, 4, 2, well, 1, 4, 5. No, that wouldn't work because 17 in 5 cells with 5 or 6 would use 1, 2, 3, 6, 5. That would work actually. So 17 in 5 cells is not ruled out. What do we have here? 4, 6, and 7. So, bobbins. So now that 9 is here, we know that we must have more than 2 outliers because the outliers have a sum of 16 and they can't be 9 and 7 because of this 9, so we need at least 3 shaded cells in this column. There's 1 here, there must be at least 2 others. And I don't see what I could do with that. Something interesting is that because of this 5, this 24 sum is not 7, 8, 9, so it uses at least 4 cells. But is it this one? Is it this one? Is it 5 cells? I don't know. Not easy. So now we know that this 3 must be an isolated cell. Oh, then this 17 can't use a 3, so it has to be a 4 cell. It has to be a 4 cell sum. So this one is unshaded. Is shaded, sorry. And now there has to be an unshaded 3 somewhere here, and 2 shaded cells. And I don't see how to decide on that. I don't think this will be decided anytime soon. But let's have a look at this 17 using 4 cells. So this must be 16. And I think there are a numbers of ways of doing that. It could be 2, 8, 2, 8 here, and 5 and 6 there. Well, we could have a 7 here and no, not a 3 here. With 7, 7, 5, 4, and 1, that would work. And this 16 would be complete. Not sure where I meant to look next. So I'm getting distracted by something else. My attention should turn to this 12, but I don't have that much information. I should remember that 3 is not available for this 17 sum, so maybe I should focus more on that. There has to be a 3 somewhere here, a 2 somewhere here, 4, 7. So the available digits here are 2, 4, 7. Now, how do I make it work? Well, do I need to check all the options? Well, why not? These are 4, 6, or 7. So there's probably not that many ways to make it work. For example, here a 2 won't work. That's 3. I should need another 14, which is not feasible. So that's not a 2, and I get a 2 in this position. Now, what about making this a 6? Making this a 6 makes those 4 and 7, and that works. No, that doesn't work. 11, 18. So, no, that's not a 6, that's a 5. And now I need another 11, so that's a 4-7 pair. Oh, that's becoming very interesting because of this 16. It could be 9 and 7, in which case this has to be shaded. It could be 9, 4, and 3, in which case this is unshaded and this would have to be shaded. Well, that's interesting, but that doesn't give me much. Something interesting is that 2 and 8 have to be both here, and they would make a perfect pair for this 10. But now I could have 2 here, 4, 9, 2, 1, making this 16. No, it wouldn't work. Oh, actually, I need 2 cells for the 10, 2 cells for the other 10. So the only way to have them fit in this column is to do this. And now that I know that 2 and 8 must be here, one of them must be here, so the other must be there as well for this sum of 10. And now we know that 21 is here with 3 digits, but there are several possibilities. Okay, so now both options are still valid. 9, 4, 3, 9, 7, and 3, 4 here. What about this 10? It can still be, it's not 3 and 7, it's not 2, 8, it's not 9, 1, so it has to be 4 and 6. I know that 4 and 6 is a word, but that's not my point. So now this is a 7, this is a 4, that's a 6, that's a 4. And 4 is not here, so it's there. And that's a shaded 3. And 7 goes there, 8 goes here. And I don't know yet whether this 7 is shaded or not. This 24 sum will tell. But what I know is that this 7 will use 2 digits and that those 2 digits are 1 and 6. It can't be 1 digit, it can't be 3 digits because 4 is here. So we will have 1 and 6 unshaded somewhere. Well, somewhere. And these 2 digits now are 1 and 5. And we know that this is 479. I won't write all of them. Well, this sum is unknown, so I don't know how many more digits I must write. But this 5 now, it contains this cell. It couldn't be 2 plus 3. It could be 4 plus 1. Well, actually, this is 4, 7, or 9, so it has to be a 4 plus 1. And that's a shaded 5. I get a 7, 9 pair, and now these 3 cells must be shaded. And not using 4 or 5 here, I think the only way is 6, 7, 8. So this is 6 or 8, 7 or 8, 6 or 7. And for this 10 to work, this has to be either 3 or 2. And I can't have more than 2 cells. And now this 7 can still be an isolated 7. Oh, sorry. This is a sum of 12, not 10. So it can be 7, 3, and 2. It can have 3 cells. Or it can be 7, 5, or 8, 4. So not sure about this. But let's have a look at this 24. It could be 7, 4, 5, 6, and 2. It could be 4, 5, 6, and 9. Well, there are a number of options for this 24. Let's have a look at this. We know now that 9 is here, and this cell is shaded. What? No. Oh yes, there's only one way to have 24 here, and that's with this 8 and this 7. It works, that's 24. So now I get this 7 and this 6. Wow, that's great. So this 24 is done. And this 9 here can only be 4 plus 5. And 5 goes here because of the 12. Putting a 4 here would put a 1 here, and it's not available. Okay, so maybe I should circle those sums that have been resolved. 17 has been resolved. Well, these first two sums have been resolved. And now I need 13, so this 8 won't work. 2 and 9 would repeat the 2, so that's 2 and 7. And I still need a 4, which could be 4 here, or 3 and 1. Oh, what am I doing? Sorry. I was looking at the wrong row. Oh, 13 is here, so it can't use the 8. It can't be 2 and 9. It has to be 2 and 7. That's 9. I need another 4, and the only way is with 3 and 1. So there has to be a 3 here. It can be 3 and 1, 3 and 1, but that's an unshaded 3 here. And I get this 6. And I don't know whether it's shaded or not. But my bet is that it is shaded because of this. If this were unshaded, I could have a maximum of 2 separators, one here or there, and one here or there. So this has to be a separator. And I need another separator here between two sums. And I don't know about this one. What I know is that this 9 is also here, so that's a 1, and those are shaded. And this 13 sum is now fulfilled. Up there I need 5, 7, and 9, and I've known this for ages, and 9 is the only unshaded cell. Here 3, 2, that's a 1. And those are 2 and 3. Now, what about this 7? It won't be an isolated 7. It won't be 5 and 2, so it has to be 4 and 3 somewhere. So this one is a 2. That one is a 3. I get 5 or 7 here. 4, 5, or 7 in those cells. 6 and 8 here. 2, 3, 9 there. I don't have much to work with. Those are 1, 2, and 6. And 1 and 6 are next to each other. So the central one must be 1 or 6, and it must be unshaded. This one can't. This can't be a 1, obviously. That is 2 or 6. I still need 3, 4, and 8, and 3 and 4 are next to each other. So this one is unshaded. 3 or 4 here. And what about this 26? I have 14 already. So I need 5 and 7 here to complete to 26, and this is a 9. So these two, this 26 are complete, this 10 is complete, this 12 is as well, this 24. Let's look at 18. We already have 5 digits, we can't have more than 5 digits. And this looks terrible. 7 will need another 5, so that won't work. And 5 won't work with 8, so that has to be a 2. 5 will work. We need another 11, which can only be done with 4, 6, and 3. No, 4, 6, and 1, sorry. That's it. 4, 6, and 1. And that seems to work. Well, it does. So the remaining cells in this row are all shaded. Now 9 isn't shaded in this column, so 9 has to go here. And I get 5 and 7. So this 9 and this sum are fulfilled. This 18 is fulfilled as well. I need to fulfill this 18, and the remaining digits are 2, 6, 4, and 5, and 4 and 5 are the ones that will do the trick. And so I get this 7, this 5, and this 4. Now the rest will be a matter of geometry, sort of, except for this 3. 3, that's the only known sum, but what remains is the number of shaded and unshaded cells. So that's all there is to it. Here I take 3, 8, and 9. Well, this is very unelegant. And that's definitely not the way to do it. That's a 5 by Sudoku. This is 1, this is 8 by Sudoku as well. I get this one here. Because that's the only place for 1. In this column, 7 can only go here. So that's a 2. And what? Oh, sorry, I get a 7 here, 2 or 6 there. Now let's have a look at those. In this column, I need 3 separators. There's 1 separator here, 2 and 3. So this one is shaded and it can't be a 3. And this one has to be unshaded. Here, this 7 is like this, so this is shaded. And now this is a sum, so this has to be unshaded. This has to be shaded. And this has to be unshaded. And this 7 sum is like this. And it resolves the ambiguity with the 2 and the 6. So I get this 9, I get this 8. This is not an 8. This is not a 9, sorry. So this one is a 3. That's a 3, that's a 6. So now I get the remaining digits. And I think I won't bother with all those question marks. I just write in the solution code just to check this is all correct. And this is indeed correct. So this was really a great puzzle, as usual with Tom Groot Kormelink. Really, really fun. The way you switch between Japanese sum considerations and Sudoku considerations, and well, that was really, really great. Thanks for watching this video, and see you soon on Sudoku.